1543, a quite different explanation of the apparent motion of the planets was published by a Polish cleric named Nicholas Copernicus. Its most daring feature was the proposition that the sun, not the Earth, was at the center of the universe. The Earth was demoted to just one of the planets. This Copernican model worked at least as well as Ptolemy's crystal spheres. But it annoyed an awful lot of people. The Catholic Church later put Copernicus's work on its list of forbidden books. And Martin Luther described Copernicus in these words. He said, "People give ear to an upstart astrologer. This fool wishes to reverse the entire science of astronomy." Close quote. The confrontation between the two views of the cosmos, Earth-centered and sun-centered, reached its climax with a man who, like Ptolemy, was both an astronomer and an astrologer. He lived in a time when the human spirit was fettered and the mind chained, when angels and demons and crystal spheres were imagined up there in the skies. Science still lacked the slightest notion of physical laws underlying nature. But the brave and lonely struggle of this man was to provide the spark that ignited the modern scientific revolution. Johannes Kepler was born in Germany in 1571. He was sent to the Protestant seminary school in the provincial town of Maulbronn to be educated for the clergy. This was the age of the Reformation. Maulbronn was a kind of educational and ideological boot camp, training young Protestants in the use of theological weaponry against the fortress of Roman Catholicism. But God to him was more than punishment. God was also the creative power of the universe. And the young Kepler's curiosity about God was even greater than his fear. In 1589, Kepler left Maulbronn to continue his studies at the great university in Tübingen. One of his teachers revealed to him the revolutionary ideas of Copernicus. Kepler was not to be ordained after Tübingen. Instead, to his great surprise, he found himself summoned to Graz in Austria to become a teacher of high school mathematics. And one pleasant summer afternoon, with his students longing for the end of the lecture, he was visited by a revelation that was to alter radically the future course of astronomy and the world. He believed that the reason there were only 6 planets was that there were only 5 regular solids. In these perfect solids, nested one within the other, he believed he had discovered the invisible supports for the spheres of the 6 planets. But Kepler's ecstasy of discovery soon crumbled into gloom, because 2 further observations by Tycho were inconsistent with his orbit by as much as 8 minutes of arc. Kepler wrote, "If I had believed that we could ignore these 8 minutes, I would have patched up my hypothesis accordingly. But since it was not permissible to ignore them, those 8 minutes pointed the road to a complete reformation of astronomy." The difference between a circular orbit and the true orbit of Mars could be distinguished only by precise measurement and by a courageous acceptance of the facts. Kepler was profoundly annoyed at having to abandon a circular orbit. It shook his faith in God as the maker of a perfect celestial geometry. And months later, in some desperation, tried the formula for the first time for an ellipse. The ellipse matched the observations of Tycho beautifully. In such an orbit, the sun is not at the center, but is offset. It's at one focus of the ellipse. Kepler's first law of planetary motion is simply this: a planet moves in an ellipse with the sun at one focus. As the planet moves along its orbit, it sweeps out, in a given period of time, an imaginary wedge-shaped area. When the planet is far from the sun, the area is long and thin. When the planet is close to the sun, the area is short and squat. Although the shapes of these wedges are different, Kepler found that their areas are exactly the same. This provided a precise mathematical description of how a planet changes its speed in relation to its distance from the sun. Now, for the first time, astronomers could predict exactly where a planet would be, in accordance with a simple and invariable law. Kepler's second law is this: a planet sweeps out equal areas in equal times. It's not as easy to grasp as circular motion. We might have a tendency to dismiss it, to say it's a mere mathematical tinkering, something removed from everyday life. But these are the laws our planet itself obeys, as we, glued by gravity to the surface of the Earth, hurtle through space. We move in accord with laws of nature, which Kepler first discovered. When we send spacecraft to the planets, when we observe double stars, when we examine the motion of distant galaxies, we find that all over the universe, Kepler's laws are obeyed. Many years later, Kepler came upon his third and last law of planetary motion, a law which relates the motion of the various planets to each other, which lays out correctly the clockwork of the solar system. He discovered a simple mathematical relationship between the size of a planet's orbit and the average speed at which it travels around the sun. This confirmed his long-held belief that there must be a force in the sun that drives the planets, a force stronger for the inner fast-moving planets and weaker for the outer slow-moving planets. Isaac Newton later identified that force as gravity, answering at last the fundamental question: what makes the planets go? The further away a planet is from the sun, the slower it moves, but according to a precise mathematical law. Kepler was the first person in the history of the human species to understand correctly and quantitatively how the planets move, how the solar system works. The man who sought harmony in the cosmos was fated to live at a time of exceptional discord on Earth. Exactly 8 days after Kepler's discovery of his third law, there occurred in Prague an incident that unleashed the devastating 30 Years' War. And he was excommunicated from the Lutheran Church for his uncompromising independence on questions of belief. The conflict, portrayed on both sides as a holy war, was more an exploitation of religious bigotry by those hungry for land and power. This war introduced organized pillage to keep armies in the field. Among the many scapegoats chosen were elderly women living alone who were charged with witchcraft. Poor Kepler thought that he himself had contributed inadvertently to his mother's arrest. It came about because he had written one of the first works of science fiction. It was intended to explain and popularize science and was called The Somnium, the Dream. He imagined a journey to the moon, with the space travelers standing on the lunar surface, looking up to see, rotating slowly above them, the lovely planet Earth. Part of the basis for the charge of witchcraft was that, in his dream, Kepler used his mother's spells to leave the Earth. But he really believed that one day human beings would launch celestial ships with sails adapted to the breezes of heaven, filled with explorers who, he said, would not fear the vastness of space. He speculated on the mountains, valleys, craters, climate, and possible inhabitants of the moon. Before Kepler, astronomy had little connection with physical reality. But with Kepler came the idea that a physical force moves the planets in their orbits. He was the first to combine a bold imagination with precise measurements to step out into the cosmos. It changed everything. This fusion of facts with dreams opened the way to the stars. When he found that his long-cherished beliefs did not agree with the most precise observations, he accepted the uncomfortable facts. He preferred the hard truth to his dearest illusions. That is the heart of science.